Right. Amazing. Let's get started. Post to a live quick. So, yeah, last stream we were working more on the brick stuff, you know, the procedural brick material. So basically we do materials all in 3D. And because we do them in 3D, we don't want to store them in textures because that'd be a lot of memory usage, both in RAM but also storing it in cache. So basically we're doing them at runtime. So procedural 3D materials at runtime. Now, we started off with a brick material. I thought it was going to be a lot easier than it's turned out to be. We've tried all sorts of things. We've tried doing sort of 2.5D in a sense where we do a parallax occlusion map kind of thing. But then now I've just decided we're just going to do SDFs and ray march into it as an SDF. And it's pretty cool. The performance is quite alright, I think. But I've just been trying to get the shape right. So we've been starting off with just one block and then doing multiple. And we've got all these different parameters like the size of a brick and offsets now and stuff like this. You can offset the bricks. So it's not just a grid of bricks. And we've also got like a cement layer as well, which is going to come back, but I'm just trying to cut the bricks at the edge off correctly. Right now they're not being cut properly as you see here. But yeah, just so that's what we're working on, is just trying to get the final shape together, make sure the parameters work well, and then we can go and color them properly because they're just colored like normals right now. And yeah, this is what we're working on today. Any questions, feel free to ask away. But yeah, we'll just start with a quick prayer and then we'll go. Father Lord, we thank you for this day. We bless your holy name. We give you praise, giving us breath. We thank you for giving us breath in our lungs and keeping us alive as long as we have. Help us just do your will. Above all, help us live like you, Christ. Help us live as perfectly as we can. Help us deny our flesh and put our flesh in line. Any sins we still commit, reveal them to us now in the mighty name of Jesus. I pray that everyone today has a good time watching. I pray that we have a fruitful time as well. Pray that good work gets done, and also fruitful conversations. I pray that we receive any blessings, Lord, you have upon our lives. I pray that we receive them in the mighty name of Jesus. In Jesus' name we pray. Amen. Cool. Right, so yeah, the thing is, right, we've got these odd brick. So even bricks are not moved. Odd bricks are offset by the brick offset. Now, I have been cutting. Let's go to the graphics material. Man, I cannot wait till we move to the next material off of this one. This one's been going on for far too long, but we're getting there. And we're finding our feet with this material stuff. It's really cool. It's going to be super powerful and awesome. But yeah, we'll... Right. So if we visualize... oh yeah, it was cut in... Right. So this border... Right, I got some notes. Yeah, okay. I think my notes were kind of wrong then, on the second one at least. So I was thinking that the reason, so we've got this border one here, where is it CD, isn't it? This is the cutting volume. So we're using this to cut away the edge. And I think, right, where's the CD then? So, oh no, it's these guys, isn't it? Can I infit? infinity. Yeah, there we go. So we've got these sort of hanging off the edge, and they're being cut right now because that's the edge. We're trying to cut them more, right? So they end up getting cut up to that sort of border box. Okay, you know what it probably is? Right, I didn't think about this. It's a bit dumb, really. Yeah, so the cut, okay, right. Maybe it's like dead simple and I just completely didn't see it. The cutting volume probably shouldn't be a border box. Oh, it be? It should probably be a box with a box cut out of that box. But this is basically a hollow box, right? And that should be the cutting volume that will subtract away. So, rightio. Yeah, that's the problem. Right, so what problems have I got? So I've got the fact that these bricks aren't being cut fully in the right places. Yep. And then I've got the problem is the odd brick. Yeah, that's that's the second problem. Right, and the other one is for the cement. The cement. So the cement probably is the same. So the cement, which is like the border, if you will, of the bricks, that cement layer, that will just be another box. And yeah, it's just a box. Right. I think we're good. So let's redo this, but we've got this lovely new border box thing, which is cool. Right. Yeah, so the code is looking a bit messy and a bit wide. We're going to clean it up once we've got the shape done. And the shape is basically done after these problems. We can clean up the code. So, yeah, the basic idea is that we repeat, it just repeats. Hang on. Yeah, the basic idea is we just put like 3 bricks down, basically. One bit up and to the right, and one forward and to the right it would be. And we just repeat. We just basically, repeat the pattern across the UV space by basically taking the UV and rounding it to the nearest multiple of that offset, and it just repeats it. And you just ray march against that. All it's doing. Now, so just got to get rid of the edges. So the way we try and get rid of those is we want to. So the box is this. Which one is it? Where's the border box? D1. This is our guy, right? Oh, so it's being cut properly now. Cool. So I was thinking that's not what we want. What we want is a box. We need a volume, like a hollow box, basically. So we'll call this the... Yes, we need 2 boxes. We need a box for the border box. We'll call it this one. The distance border box. This would be the size of the volume take. There's a thing somewhere in there. Border deepness. So where's the brick dims? I think it's that. So brick dim is how... Hang on a minute. I think it's one take Z brick dims. And then let's just try that. That might be a little bit too far. But, you know, we swap it out for a D1 as a full. Right, this has got to be half dimensions. Times 0.5. Right, that's cool. So it's taken one brick off there. Now, now it's border deepness. So from this point, we want to allow some kind of like, the deepness could probably be another half brick, maybe. Uh, times this plus 1, effectively. So, oof. Something like that. So if we see this in action, so we want to min that with the union it with the bricks themselves, D0. Right. So your border deepness, I think this is a little bit off. Get rid of that for a minute. Okay, so we're taking away, so here's the border now, so it's going straight through the kind of centers of the bricks. So actually I was thinking of going that as the furthest. So really what we're looking at is like probably multiplied by the Z brick, border deepness. So now if the border deepness is kind of, oh, hang on a minute, that's not what we want, is it? No, sorry. So that's, huh. You moved away half a brick. No, you see, I wonder if there's something different we have to do. So there's a number of, oh no, yeah, so oh, my laptop died, damn it. Right, I can't see chat for a minute. Let me get my laptop back up. Okay, so from the edge we've done one takeaway, then the distance, the sort of to the middle of the brick. So it's half a brick basically. And yeah, I think we want this, right? So if you've got, well, it's not really. I was getting the chat back up. Right, we're good. Chat's back up. Cool. All right. So this means we want to kind of like choose how much of this distance that we're moving away. Oh, so if obviously times that by 0, it's going to just make a full box, right? And it's going to cover the whole space. Then, yeah. So, but the amount we want to go up to at most would be brick dims take away border dims. Yeah, so brick dims includes the border dimensions. I need to sort of rename this stuff a bit. But it's just made it easier to do a lot of the maths that we've been doing. So I think what we need to have is something else. Yeah, I've called this brick half dims as well. It's a right nightmare. But yeah, so you want to basically tweak. So I think you want to go back a border dims. Oh yeah, what's that edge dim? And that's the roundingness, isn't it? Right, I see. So yeah. So this is the actual brick half dims. So you actually want to take probably the border dims. And then from here you're taking the brick half dims. So take away another brick half dims. But multiply it with the border deepness. Oh, come on. Oh, I didn't times that by 0.5 as well. Looks a bit off. Right. Cool. Yeah. So now if this becomes 0, it's basically completely filling up. Right, it's probably not what you want, if it is quite close. But 0.1, there you go, it starts peeping through. So you probably want something like that at minimum. And then, well, you just sort of got a little bit poking through. Then obviously going all the way up to 1 will get you that. Cool. That's the border deepness. So border deepness probably needs to be times by 0.9, offset by 0.1, right? Such that your 0 becomes 0.1. You don't want absolute 0, yeah? Cool. Yep, and your 1 stays a 1. Lovely. Now, I'm glad that's in a good place. So we want to get a proper cutting volume now to cut these edges off. So all these offset bricks, so these are the regular bricks, they're going fit nice and snug going across here, but the ones which have been offset by whatever brick offset X is are the odd bricks. Now the ones on the edge, we kind of got the cutting volume a bit wrong. So let's work on the cutting volume. The cutting volume needs to be a box inside of a so this D border box that we've just been working on, D border box needs to D border box needs to cut out of a full box. So we'll need, let's bring D border box up here. Now the cutting volume, so we'll call this the uneven, the distance uneven cut volume. So that would be basically your SDF subtraction. So we're subtracting from a full box. We'll just do a full box here. We'll just call this the distance for a volume. Yeah, it's just the UV volume basically. And we'd like to, so you do a D volume, subtract away an inner box, which would have been the D border box. So now you've got a hollow box, right? We'll render it, but we'll basically see a full box because it's hollow and we're looking at it from the outside. I think. Hang on a minute. we clearly have some issues here. Why is it? There we go. So, right, no D1. I need me a D1. What's going on with D1? Ooh. Yeah, full box, but already peek inside. It's a hollow box. Now, how do we prove that? Well, where we have the CD, if we replace that with D uneven cut volume, right, D0. Hang on a minute. Right, so as you've seen, now these bricks have been cut on top. Doesn't look very nice, unfortunately. About that. No. I've got some weird artifacts right here, tell you that. So maybe that wasn't the right thing to do. They cut those off completely, which is interesting. You know, rather than doing these cuttings, we could do a finite repeat. And the finite repeat might be what you want. Because that means then then you can repeat it 4 times and then just be, yeah, I think that's what we want. And then we won't have to make these cutting volumes. It's less maths, and that way less computationally taxing, you know what I mean? So yeah, we'll do that. So go back to Indigo Quillers' lovely, lovely website. And we would like to find the repeat stuff. Hang on. We want this limited one. Here's what I'm going to do. You're amazing. I'll call it Gridify, but maybe just call it repeat. I don't know. It's shorter. Let's call it repeat. So just, you know, rounds it. It's just like a... So it rounds up to the nearest multiple, that sort of thing, yeah? So we want to do that, but like a finite version. Repeat. Call it finite. Something like that, yeah? So position. This will be known as the spacing. Made mine a vector 3, didn't I? Spacing and L, I guess, means it's your sort of range, right? Isn't it? Basically, it's your min max. It's your, what do you call that? Well, bound, right? Then this would be like, it is kind of pseudocode for like a 3D function. We don't need that because all we're interested in is the return value of this. So we can just, you know, have, yeah, don't have to keep calling the same function. All right. That's going to be awesome. All right. So we'll repeat finite infinite. Lovely. Lovely. Right, so let's go to the brick. Oh, we're right here already. Okay, here we go. So, we basically, this one's going to be an infinite. No, they'll all be finites. So repeat. You know what? Let's call it. Let's make it explicit. All right, here we go. So the first one is just a standard. You know, it's just the standard ones. So that's just a repeat. Now the bounds, we'll call it bounds. So the bounds is actually the brick counts up here, right? That's an interesting one, isn't it? So it's just brick counts. Hang on a minute. Well, no, it's brick counts at 2.5 though. Hang on, how does that make any sense? Oh, crap. Right, so you divide it by the spacing. So how many do you fit? Oh yeah, how many? Bound it within that. Lovely. So yeah. So we are looking at like 2.5 or whatever it is, I think. At that point. Oh, okay, cool. I think that'll work. So what we're looking at is your bounds. So we'll just call it vec3 bound. So that'll be the vec3 version of z brick counts. So it's a three-dimensional counts along each, along each axis, the number of bricks. So there's your bound, and that will be divided by 2. Yep, nice. Now, when you do a repeat, you're doing a finite version. And what you're saying is we just put bound in there at the end. So that should limit. Hang on a minute, let's try this out. Let's just change these quickly to the 3D repeat infinite, and hopefully it doesn't break anything. Right, I ain't got a P defined somewhere, hang on. Right, apparently that reloaded. No problems. No changes there. Good. So what I'm looking at doing, to be fun. So, right, let's rewrite some of this code. So these ones which have been offset, the odd bricks. Right, let's get rid of this terrible cutting volume stuff. We're not doing the cut volume way anymore. Bad idea. We could just limit using this grid thing. Far less computation. And should be fine. So let's bring that back. Right, they're here, the offset bricks fully now. So we want to try and trim these guys off, right? How you do that is we do a new bound. So the bound would be that take 0.5, maybe. You'd be like, hey, bound minus equal 0.5. Along the x though, right? Yeah. And then you would basically change that to, yeah, it's very wide code, terrible code. We're cleaning this up in a bit. We're just making sure it works first. So what we're looking at trying to do is get rid of these extra bricks on the end here now. So we've bounded the repeat to be finite. Well, that went kind of weird. What's going on? Ooh, that's interesting, isn't it? So, sort of. Right, can I bring that camera back to a good place? Because I don't like that camera not being Hopefully it just reloads. No, got a crash. It's alright. Oh, my tea might be ready. Let's give it a taste. It's all there. Lovely. Right, I've got the camera in a good place now, so we can see a bit more wider view of the area of the stuff we're interested in. Okay, so it is cutting them off. It's interesting. Oh yeah, it's kind of offsetting it. So yeah, interesting. Interesting. So we take off 0.5. Let's take off nothing. Yeah. Yeah, why are we getting why is it making it fuzzy now? I don't like fuzziness. What's going on here? Oh, I got this brick thing. Let's get rid of that for a minute. Yeah, it's trying to add the roundiness. Yeah, so what's happening is the ray hits the surface. It's like, oh, there's a thing right next to me. You know, basically, when it tries to get the distance to the nearest thing, it's basically like there's a hit. So that's why we're getting this sort of like noise, is because that, yeah, it's like there's a brick which is there, kind of thing. So what's happening is, it's yeah, it's not good, basically. Why is it? Oh, it's clamping it to the edge, so hang on. If it clamps it, is that going to cause... But why weren't the other ones causing those problems? Why is it just you? Oh, yeah, because these are offset by an up... Hang on a minute, they're... Hang on. It's because these are... Yeah, let's go to these for a minute. Rewire it. So we just return pos, we can see what we're doing. So basically we've got one which is like in the regular place. Maybe it's this one, I think. And the other one is like back to the left. And the other one is down to the left. And we're repeating this sequence because we're just basically rounding the UV to the nearest range of the spacing. So you have a spacing of let's say the number 2. So every multiple of 2, it's sort of doing that. But it's between 0 and 1. Oh, sorry, minus 1 and 1. That's the range of the whole area. But yeah, something like rounding to the UV to the nearest multiple and just repeating this whole sequence, and it just builds, you know, what we're looking for. Now, so if we're causing it to go, well, maybe it's not down because there's only one brick. Oh yeah, it must be down. Yeah. So and one is to the back. I think it's because we've offset them and they've gone outside the zone. It's causing these artifacts. These things we don't want. But it's only happening probably because of the clamp. Wasn't happening without the clamp before. Because the clamp is going to clamp the UV. That means if it's inside the volume, it's going to get these artifacts, I think. So is that right? Mm. Mm. Let's have a play. Let's change this by 1.5. Interesting, eh? Yes, you're seeing it sort of appear here over those fuzzy volumes, yeah? But before you're not. Right, let's times it by 0.9 or something like that. Yeah, I can't. It must be just due to the nature of the clamp, but let's see. So which multiple have you bounded it to, basically? And then it's just okay. So which multiple have we bounded it to, and then I wonder. Yeah, we're still getting the sort of fuzziness around here. Well, it does help solve our problem in a way, but it introduces this other one, which kind of sucks. Bound.y take 0.5. Let's try that for a minute. Oh, that helped. Lovely. That's what you want. I don't know why. That's amazing. So maybe just bound 0.5 the whole way. So yz minus equal 0.5. Now, all right, I'll take it. Hang on a minute. We're still getting issues with the fuzzing here, though. Oh, that's on the X side. Fantastic. We'll clear that up in a minute. Anyway, so the X needs a 0.5 as well. Cool. I like it. Now, the issue is we actually want the left done cut by a slightly different value. So, yeah, I think we're going to need a finite with like a min bound and a max bound. So that's just an overload. So the min max. Wait a minute, not negative min. So the min bound is going to be bound, negated bound, plus Maybe it's a whole one. Yep. Lovely. Lovely. So, mid-bound. Hang on. You make my life feel brand new. Oh yeah. Look at that. Oh crap, we're still getting this sort of artifact though. So that's on your standard bricks though. So your standard guys still have the same problem. So that's for some reason you're amazing. I wonder how much of this is yeah, we're still seeing that fuzziness here, you see. Yeah. Hang on. Oh, the fuzziness is not on this one, it's on the repeat one. So are you telling me that we need a little bit more on the X? Another 0.5, you saying that really? I'm confused. Why am I seeing these one? So this is obviously someone's in the more in the background. What does it get us to move these bricks here? Is that? Yes, there's this upper bound here, but if we do that, it really sabotages. Oh, it affects. Lovely. Oh yeah. Look at that. Right. I'm happy with that. But actually, hang on a minute. Can't we just take 0.5 from the whole bound? And then drop that one. Oh, there we go. Cool. So I think this is basically what we want. We just got to change, tweak some of the parameters just to make sure everything still works. Change the number of brick counts, change the offset. Does everything play nice? And then we can clean up this code, make it read good. Because right now it's just a mess. But this is basically what we want. And the maths ain't too complex. So going over this is 0.74 milliseconds. We haven't really tried to optimize it. Yeah, we're looking at probably a millisecond for a material. I'm not sure though. I think it's 0.34 milliseconds just to shade anyway to do all the PBR stuff. So we're looking at, yeah, probably a millisecond per material at most, if you will. We'll see. We'll see how it goes. I don't know. Yeah, we can have a play about. So let's tweak the parameters. So the brick counts. Yeah, we've got to play about the roundiness as well, but we'll get there. It's basically all there. The shape is there. Let's put the border in. So SDF 3D Union it's called, which is basically just a min. We'll do the border box as well, yeah? Cool. Does that not want to work? Did I already do Union in the end? Oh no, it's just SDF in it. Just makes, there you go. So you got the border around it. Lovely. Ooh. Hang on. What you complaining about here? Oh, did we drop my... Oh. The Z's are missing. Hang on. The Z bricks are missing. That's not very nice. So why? Did that happen since this? I think it was since the min. Oh, we only really want this on the X. The +1 on the X. So it's min bound dot X +1 equal 1. Oh crap. Oh yeah, we need to take 0.5. Boom. That's what you want. Lovely. We're back. We're back. So there's the your sort of cement layer looking good. So we can add all the roundiness and get coloring and all that. So it's good in a bit. That's looking a bit strange, not gonna lie. But maybe that's just because it's to the negative side and we're shading it based on normals. Yeah. Cool. So we just want to play about with some of the input parameters. So if we take, say, for instance, the brick counts, right? Let's see what happens if you make it odd and even. So we'll do 4, 5, 4, 5, and 6. How does everything play out? Right, there's some there's some problems to the 4. So let's just start simple. Where it was on 5, 5, and 5. Let's try 4, 4, 4. Right, so now evens have a problem again. We had this problem before because we weren't sort of offsetting the bricks and stuff like this. But yeah, we just go back for it 5, 5, and 5. Yeah. So we had this issue in a previous iteration. And there is this even num brick offset thing, right? It is in here. I thought it was doing a thing. But it seems like it's not doing the thing that we want. So let's just try to comment out, see what it does. Right, that seems to be better. The problem is though, yeah, I don't know. It's got to analyze it some more now. So, so if we take away the brick offset, this might have been introduced because of the brick offset. So we put 0 in there. Right, there's still a problem. Oh. I wonder if the 0.5 is playing anything into it. Yeah, it sort of is. Yeah, so you only really want that if it's odd. So you want that 0.5 if it's odd on a dimension. Yeah. But no, you kind of need it. If it's odd on a dimension because you're getting the fuzzy, but you put it back, fuzzy gets, so it's still kind of there. It's fuzzy on some of them. Yeah, there's some stuff to do. Right, so I guess let's do that. This would be called the sort of bound, uneven, bound offset. So basically, this tells you if it's even or not, right? So you can call this the sort of even. This would be the sort of is even vector. Basically, so we just do that, is even. Right, so this is just looking for like an is even. And then for this one, you want probably an is odd. Uh, is odd times by 0.5. Then uneven is odd even. Um, uneven. And sorry, I didn't do a not, did I? Hang on. You want to XOR you want an XOR one. Yeah. Right. Then minus uneven. Sorry, wrong one. Bound offset, lovely. Right, why aren't you working? Yeah, why am I calling it uneven? Let's do it odd. No, sorry. This is an odd number, but they're going to be... Yeah, I got this completely wrong, and I... So why have I called it even? Oh yeah, because then I've done equals 0 instead of equal 1. So that is even, and this is odd. So... Right. Okay. Right, this makes a lot more sense now. Yeah, so rather than uneven, we'll just call it odd, okay? Right, so that's fixed that problem. You know, we can change back to make it 555. And it still kept them in check, which is good there. Cool, cool, cool. So go back to being fours. Now let's fix these up. So we need... So the ones which are in the right place are, I think, these guys, this layer here. Right, this is an offset layer. And this is like... So let's just view the... let's just view the standard layer. Was I right? Yes, it's this layer here, right? This is correct, and this one's the standard layer, okay? So the other ones are kind of offset. Now, if we just draw them without the repeat, that's a bit odd. There should only be like 3 bricks. Oh, oh sorry. I've got 2 finites now, and I... Yeah, so slightly to the right and down. Yeah, down and slightly in front. Cool. So we should keep seeing this pattern, right? And we... Right, but the one below keep... Ah, this is interesting. Yeah, So I think we need a fourth brick, which I don't really want to keep doing all that maths. It's a bit much maths, but yeah. So what we're seeing is a problem we didn't see on the odd one, where we had an odd number of bricks, because it was actually just under the layer below, and you can kind of see it here. They're all next to each other, yeah. So the layer underneath this one is just kind of a grid. I didn't see it until this, right? So the one below. So what we need to basically do is, I wonder if we can minimize the amount of SD box functions we're doing. Basically, they do require some length operations, and it seems like there's quite a lot of dependencies on some of these. There's a lot of there's a min of a max, right? And lots of little dependencies, and good if we can minimize these things if we can. So we're already drawing like 3 boxes just to draw the whole pattern, right? So it would be cool if we could draw it all in, maybe less, I don't know. So we could draw 2, and then maybe, no. Right, let's see hang on. Let's just see what we got. So it would be great. So basically we've got to do this and then repeat it on the layer down and forward, right? So the Z and layer below, right? That's what you kind of want to do. So if you just do 2 box functions and then the problem is you cannot shift the view. Sorry, what am I trying to say? You cannot shift the UV, the sample position, based on where it is in the layers. Because if not, when you do your ray marching, you're kind of lying. If I draw it, will like you'll basically be lying to the ray marcher. So if we have this ray which goes down here, and you're ray marching, right? So you'll start here. You go, how far away is this? It draws a big old sphere kind of thing. Really big. It gets you a distance, right? So you're like, oh, the closest thing is this far away. We don't know which direction it is, but we just know based on the distance, right? And then we can step up to here, and then we keep doing, hey, what's the closest distance? What's that? So we go along here by that and keep going, right? So it's just very marching. Now when we get to a position about here, we could, is what I was about to say, is we could be like, right, you've now passed this layer. So the brick, so when we do this sort of rounding and stuff like this, we could offset it by the brick offset. And rather than the brick being here, it's now magically here because the sample point is passed there. But then you're kind of lying, because when you did a distance here, you just have to be very careful, because you could have very tightly packed bricks, maybe, and you can end up basically stepping into this brick if you're not careful. But I think they're far enough apart that it might be okay. But yeah, so basically what I'm saying is, when your sample point is here, this brick is technically here, right? In a sense, when you've repeated it. But when your sample point is here, the brick is magically here, and you've, right? Oh, and also, hang on. This brick up here would also be here since it's a repeat, right? So actually what will happen is you'll get a very small step distance because of that, and you would then do that. So there's those sorts of things, right? That you'll be playing with. But I think it'll be fine because they're bricks, right? And maybe then it will minimize the maths as well, and that's what I really want is it to be cheap, right? Cheap as possible. That way we can just call it multiple times. I don't really have to care about some of the iterations. So what if, right, we just did, hear me out, 2 bricks. And they're just offset like this. Now I feel like it's going to have problems. So you could just repeat 1 brick, and then depends on where you are, you sort of apply the offsets. Maybe. Should we try that out? If you have 1 brick, and it's just repeated. Try that for a minute. 1 brick and it's just repeated. Now, right. Let's scrap this one. Well, not scrap it. Back it up. Try again. So I'll leave that one just in case. So the idea is we'll have 1. The repeat is going to be uneven brick offset. So without that, things will just be too. Yeah, one of them will still remain middle, basically. Then. Yeah, get rid of that Y and Z. Cool. So you got your grid of bricks. Now, what we want to basically say is if you want to know like where in the index like a brick chord, right? So what's your brick chord? So brick coordinate be like a floored. I guess I'll floor it automatically. Ooh, you're looking for like a, hang on. You're looking for an integer version, signed in. Then you're sort of saying, bound. Yeah, you're dividing your current UV by the brick counts. Spelled that word wrong. Brick counts. Yeah, you've probably got to offset the UV via this sort of brick offset as well. Yeah, so this will land you basically, give you an index into each. Yeah, three-dimensional index. Yeah, but when it's even, what does that even mean? Because yeah, so I guess this one will be 0, this one will be -1, right? And that'll be yeah. So it's cool. Now, effectively, if record dot y is odd, apply to the UV. Apply. Yeah, apply to this UV. Brick offset X. How's that? Hang on a minute. How's that doing it? Oh, times brick dems. Right. Okay. Cool. 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 So it's already. Yeah. So we just apply Z brick offset X. Yeah. Yeah. So let's try that. So what you're doing? Brick counts. Right. It's not Boolean expression. Now it is. Right. That's done. Not much. Right, I think the hotcode reload is busted because surely that must have changed something. Okay, it hasn't. There's So what I'd like to do is say the ismouse app. And I'll just take a little look at this and see what's going on. Right, so clearly what we're seeing is a load of rubbish going on. So it's just a bunch of zeros all the time. Why? Good question. Oh, brick counts. Hang on a minute. Brick dims. Right, so it's added like to the UV in all dimensions. No, along the X only, please. Cool. Hang on. Hang on. If the Y is odd. You're getting sort of cuts. Yeah. You're seeing the cuts which I thought you might get, but I was convinced myself that it might be okay not to do it. Yeah. You see, you're changing the geometry every time you go over a grid. But, hang on. It's probably because the, this thing. Okay. Right, it might be okay if we align it with the bricks properly. Brick dims times is even, yeah, it's like a half a brick. We're moving it around, that's fine. So if I move the UV by half a brick back, then divide, it's a problem, but get rid of that. It's mostly fine, but then why are these repeated? Oh. Okay, good, good, good. So we don't need the offset. Right, so if we put one of them, the ones on top have been offset. Hang on. Oh, minus, hang on, so that would be odd even, yeah, but it would be fine. It's and one though. Yeah, it should be fine. Right, let's see that again. Right, so something about these two. Let's see those coordinates. Right, so we've got 2, 0 coordinates on the y. So that's because it's doing a round down. Yeah, kind of thing. Yeah, it's got 2 zeros. So what we need to do is offset you by brick dim. Yeah, I guess we can just do an unsigned one, yeah. And that would basically say UV plus, brick dim multiplied by the number of bricks, something like that. Maybe a bit too many there, but let's just have a look for a minute. Right, let's sort out the problem a little bit, but let's see the coordinate system. So that's 2, 2. Where's 5 already? Yeah, it's too much. So clearly this needs to be like a half. Right, there's your 0, 0, your 1, 0, 0, 2, 0, 0, 3. What's that one? That's your 0. 0, put 1 on the y. Perfect. What you want. So then we offset this one's here. Cool. So it seems like it's working, even though we're doing something completely funky and kind of crazy by modifying the terrain as you step through the, modifying the SDF as you step through the SDF, which is not great. But because there's separation between the bricks, it should be fine. Should be fine. That should help with the performance, we think. Yes, that's saved. I think it's saved around 0.2 ms. So that has been good. Right, so let's yeah, so this is the good. So we've got the even number of bricks working again. So what I'd like to do, yeah, let's keep that. We can clean it up in a bit, but let's keep going. So let's put the border back. Right, okay, the border's wrong. We've just got to fix that up. So the border, if we just render the border, D border box. Wow, this thing has been completely fried. So this is what happens when you change the volume as you step through it. But yeah, so obviously we've just gone and buggered up. So we just take this and put up before we do the changing and brick half dims has decided to not be declared. So sorted you out there. Then we simply just give it a render and yeah, it's kind of what we want. Although, does remind me, we ain't got the cut volumes anymore. So based on the bounds, the min and max these guys is yeah. So we have this thing called bound, right? If you have one of these, right? If one of these are true, you do your min. Yeah, all right. So we just have a thing called min max bound. Yeah. So you have an offset added if any of those are true. So if any of these are true, yeah, if any of those are true, then apply that, please. So I guess you could probably make this like, you know, branchless. Ta-da. So that's your min bound. Hang on. Why you no work? Are you saying that the max bound has to be moved as well? Oh yeah, because that's affecting the wow, it's really affecting, isn't it? Yeah, because that's now making it very big steps. It's not good. So I think what we want to do is we want to make sure that our step size never exceeds a brick length, maybe. That is going to affect the performance though. Ugh. But you are going to be starting from the surface anyway, so it's not going to be that bad of a problem. But yeah, I think we want to say, okay, so I think do. Right, sort that out. That's rather interesting. Yes, that brick offset is because we've moved it to the right. We want to get rid of this one only. Oh, come on. That's only if it's an offset, right? So while we're trying to render this one, is moving the bound backs. If any of the X or Y's, oh. Hang on, so hang on a minute. If the thing is offset, if it's odd, an odd 1 and odd Z, it's going to also offset both. Is that? Yes. Wait a minute. It's doing I think we're looking at. Yeah, I don't think we need the branches. Let's call it off for a minute. We can figure this out as we go. Maybe not. So they're ones. 0. No, the ones there. Hmm. Okay, so we got the coordinate and that offset thing. So 0, 0 is fine. Your Y offset, obviously a 1. These should all be offset by X's now. But why? Oh, sorry, it's off times the brick offset, isn't it? So Z, which is 0 to 1. Cool, that's great. So it's kind of branchless there, kind of. Hang on, but why? Right, so you're on a Y level. So I think it's an XOR, isn't it? Oh, maths. Lovely. So that's cool because now it's branchless. I like that. But now we've got this horribleness. Right, so we're getting these artifacts because we're changing the geometry as we're stepping through it. Very dangerous. So, and basically these bricks end up, these bricks that were here used to prevent it, but now the step size ends up being quite big. So if we show you what that is like, you see, so we might have to limit the distance that you return back. So basically if we take the, what are we taking exactly? We're taking we want to see the distance, that's for sure, but we also probably want to see the brick coordinates, see the distance. And we actually want to see the size of the brick as well. Anyway, the size of the brick is going to be z dot brick dims. Yeah, I think so. Right, so as we're going to draw that pixel there. Right, so as you see on the left-hand side, you have this FFF over here. That is basically a start of, after that one's the start of a new frame, if you will. So there's 3 prints per step. So we've got 1, 2, 3, 4, 5, 6, 7 steps in the ray marcher. So what we're seeing, so the distance is it ends in 8, 9. It's just a single floating point value. Those ones have a step size that go at most, the highest being 0.2. Now, as we see, there's a vector 3 of 0.5, 0.5, 0.5. That's the size of a brick. So effectively, even stepping a nearly half the size of a brick, say 40% of a brick, is still too much. So we could say you can step up to most, maybe border dims is the most you can step by. But then if your border dims is very small, isn't that going to make it impossible to step? But let's play around with this because we've got to see, right? So D0. So we want to sort of like, so obviously negative is inside. Yeah, just return the minimum between, and let's just do border dims. And we'll pick the min border between, min element of all those, yeah? Okay. That's still not done it well, that's really bad. That's horrendous. Right, let's just hard code it 0.01. It's done all the steps and it's run out, I think. Right, so you got that blue, that's where it's obviously hit max iterations. Okay, so clearly that's okay. So we try one. Right, so we start to see problems. So what's border dims? Right, 1, 4, 9, whatever, right? So if we go to 1, 3, you start seeing problems. So basically what you'll need to step inside by is probably border dims half. But then that's like, I just feel like that's gonna be really bad for performance. That fixed the artifacts. But the smaller the brick, because we've got that, this is the there it is, 6.5, yeah, 0.65. So if we get rid of that clamping, right? So that didn't actually impact performance too much. It added 0.01 milliseconds. So the extra steps are not that bad, which is cool. Hang on. Oh, we had some print functions going on, so it was probably, yeah, it was like 0.01. I think sometimes, yeah, we've got these print statements happening, which ends up writing memory out to a buffer. So plays. Right, let's keep playing about with this a bit. So the next problem I have, oh crap, what's going on here? So now this has made it such that I feel like that bound there. What's that complaining about? Gotcha, that was an easy one. So this one we want to multiply by if it's even or not. Wait. Is even. Along the x. So we, something like that. Cool, looking good. So let's just keep up in the number of bricks and see if we bump into any problems. Performance is not staying that bad either also. We're not seeing those horrible performance, artifacts because we've... Okay, that's good. I'm liking that one. Should we change the border dimensions for a minute? So border dims, this ratio here. So it's just a ratio, right? So ratio 0.1. Right, that's not, the performance ain't too bad there either. And we ain't got the artifacts too. So even if it's like, to do that, it's going to be a crash, right? No, it still runs fine. Oh, hang on a minute, because it exits on the first thing. Yeah. So we did that. Very, very small borders. Where are we going to see? Right, now you start to see something. Here we've got some... Okay. That right there is because we've reached the maximum step size. We've got to kind of fix that sort of bug if we can. That would be great. So when we reach a maximum step size, you're not... I think in this case, you've just reached maximum step size, and therefore you've moved the UV, and I think it's doing the normal based on that. And for those, I think it's okay because we can... Yeah, I'm not too sure about that, to be honest, but yeah. So we'll probably color the brick based on something. We'll see what we do, but we'll think about that one in the future. Right. That's good. I think I'm quite happy with the technique there, and yeah, and this border size, right? You know, it goes all the way up to 1, right? Being the whole brick, so you can have... Right, there's a roundiness parameter we've got to mess with, but overall... Yeah, let's just leave this for a minute. We can come back. The edge dim is like kind of like a roundiness, I think. Um, so it's recorded in dim. In UV space. Yeah, it's a bit problematic. So that would mean you probably want some kind of like ratio of some kind based on the brick size. So stuff we could play about with. So that's probably probably just want to call it roundiness, right? It's really great when you can just call stuff, round, ness on the end, roundiness, bumpiness. Um, but yeah, I like having variables like that. Cool. But yeah, I'm just gonna take a quick break. When we get back, we're just gonna, go over the rest of these parameters, make sure they're all good with the code, and then we'll clean up that lovely distance function, and then we can start trying to add color to these guys. Right, we're back in a few, just getting a drink. If you have any questions, feel free to ask away. Beep, beep. Right, welcome back, everyone. Oh, got some snacks. Right, let's go. So, what's next? Brick edge dim. Dim is too scientific to it's a measurement in UV space. Not very practical when the number of bricks can change. So probably best to call it roundiness. Be much better. Because as if we change the number of bricks, it stays the same size no matter the brick. Number of bricks. So let's change that. So brick and code. We'll call it brick. What's unevenness? What does that even mean? Oh, that's like the wobbliness. Yeah. uh yeah. So you got roundness and unevenness of the brick. Yeah. They're good. I like those. So let's look for edge dim. So edge roundness. Yeah, I could stick an eye in there, make it roundiness. I do like the idea of roundiness. So graphics as well. Gotta change it there. Now, so that is the percentage of. Yeah, I think we'll want to find a good min max. Right, here we go. Man, this is awesome. We've got to try different dimensions of bricks along each axis, so I think that should work. All right, here we go. So the roundiness. See, the problem is right. So the roundiness is going to be multiplied by the brick dim. Now, the roundiness is taken off kind of from every from like an edge, meaning you probably want half of that. It to be half, and that's just be a vector 3 then. No, you probably want to pick the min based on the min. The min element. But then if you have full roundiness, it basically makes a circle. Right, sorry, a sphere. Which would be interesting to see. Whereas there's kind of too many bricks here, but right, let's try it out. So more roundiness. That was only 0.3 though, that's not nice. Alright, well that completely messed up. Oh yeah, so part of the other problem is my roundiness is a bit buggered at the moment. Because what it's doing. Ooh. It's plus the radius, didn't you? Where you at? There you go. Oh, crap. That's affecting... Got some artifacts here, that's not nice. Oh no, this is not good. So we want to make sure we can change the roundiness so it doesn't change the sort of size of the actual brick. This is the thing we're going to try and solve now. So it used to like offset. So there's the SDF box. 0 roundiness here. But we can just chuck the roundiness in there now. And the reason being is because I used to have them separate, so I was thinking just get one SDF and then change, just deduct the roundiness off, but that will shrink the volume. So I think that's what you want. Now, that means inside... Yeah, I wonder if you'd like a border roundiness as well. We'll just reuse the brick edge roundiness. Cool. I think I see some artifacts, so I'm not sure though. No, it's looking alright. I think. Yeah. So let's bring up the texture viewer. Sorry, wrong button. Here's our boy. Right, this kind of looks a bit worrying. But actually, it's probably just because of the camera angle. And the... I don't think you hit max iterations there. We can check. Well, no, if you hit max iterations, then it means... Oh, no, sorry. Yeah, so if the border dims is high... Ah, that's right. Yeah, you probably... Okay, I see the problem. So you probably want to step by a min between Z brick dims and because your border dimensions could be bigger than the border dims. That's interesting, yeah. So actually, my brick dims currently means the size, the spacing it takes to get from one brick to the other. So I should really call that brick spacing. But we're going to be renaming that in just a minute. We just want to make sure the code like logically works correct and we can tidy it up. We will tidy it up. So it's either min between that and that. Lovely. Yes, that catches some other problems, I think. Yeah, that's not really changed anything, I don't think. But yeah, but at least that's caught a problem in the future. And we'll write comments around why we got this thing in here. Okay. Oh, this is getting good. Okay, so the next thing to look at would be... So that's the roundiness. Yeah, we don't want to change the roundiness. How round can it go? That's the fun thing, right? What's the... Right, so you should be able to get a sphere basically. But then like that's more than a sphere. It's like, you know, 150% sphere. Hmm. More like 200 probably, isn't it? So I think what you're looking at is doing a 2.5 on that. And then voila. So 1 would make it that sphere, basically. There we go. Ain't that fun? Now, so you probably most of the time want like a 0.1. Now, if we scale the bricks, so let's just say you're going to have 2 bricks. Well, that's interesting, I guess. We need more than that. 4 bricks. It's a 0.1 of those 4 bricks, but if you do 9, it's like the brick looks the same but just smaller, if you will. So that's cool. I like that. You know, let's do a 4, 5, and 6. I want to see how that looks. Right, that seems alright. So they're more condensed along the Z because there's 6 of them going that way. We got 4 going across and 5 going down. I think that looks alright. Cool, I'm happy with that. Nothing's busted there, but let's keep it even again because it's just easier. Right. Gloss min and gloss max. These one like bricks which are glossy, but we're not doing the PBR bit just yet. We're just doing the normal map and making sure the geometry is good. The coloring will come in a bit. But we're getting very close to it. Now. Brick Z, we've just got to get rid of it. Brick Z has got to go. We'll do that on the cleanup. Color edge, coloring. Now the unevenness. Oh yeah, that comes. Hang on a minute. Unevenness comes as part of the remarcher. Yeah, I just realized as well, we can't make this work for a sphere as well. The sphere behind looks busted, but yeah, so you can't really make the sphere of with the approach that we've done. I don't think it's necessarily a problem. But the approach that we've done means that the sphere is probably but if you made it, have a bit of a play here. Not that you'll want to do this, but maybe you might. I don't know. I'm not going to keep this, but I just want to see. Yeah, so I reckon you can change the border out. Where's the border again? Oh yeah. Interesting. I reckon you can do like UV and whatever this. You know what, sphere. Then min element, let's say that. Right, that thing busted. Hang on a minute. What are you complaining about? Yeah, so it's worked because we just made it a sphere, but it's just cut. Well, that's on the negative side. Let's look on the positive side because right, I meant on the positive side of the X, not positive side of the way of thinking. You know, it's a normal map, so the colors are a bit maybe off on the negative side. But yeah, I guess it sort of works. You've seen it smooth. You know, maybe. But the idea is that we're going to have these paths possibly. So we have a volumes of bricks, that'll work. And we can pass in like a tangent and bitangent and remap. Or sorry, what's the way of saying it? We can put the three-dimensional UVs such that the X will increase along the wall, the Y will increase up the wall, and the Z will increase down the depth of the wall. And we have these tangent and bitangent such that we can sort of rotate the ray marching ray into the right space. And that, you know, if it's deformed, right? So it's going to have some, it might look slightly off in some ways, but it will basically be fine. So I don't think we'll need to do that sort of sphere thing, but it was fun to sort of just quickly play about with. And plus I've got my sphere function there for when we need it in the next things. Anyway. Cool, so where was we before we took that little minor detour about looking at those spheres? Yeah, we'll have materials that can work with other things. But brick walls are basically brick walls. Right, nothing. You know, I guess you might want to have a brick wall which is like cut and stuff like this, but maybe that could be a different kind of shader. Well, you can have geometry which basically cuts this one out, so there's things we can do. Anyway, moving on. Yeah, unevenness. We want to put a bit of noise in there. Right, this is where we take the performance and throw it out the window. So let's just hope that is good. So we're looking for a kind of wobbliness. I'm seeing some artifacts on my bricks for a minute. Not very nice. I think that's just the nature of the roundiness and probably the normal colouring. So, anyway. Anyway. what are we looking for exactly? Yeah, the bumpiness. So the problem with this function is that it will be called like many times. And three-dimensional noise is quite, what can we say? Expensive. But you want the brick. Hmm. Alright, here's what we do. Yeah, so the brick needs a noise pattern, which is probably different for every single brick. So we could take, yeah, but there is a sort of faster noise, the value noise. This one, maybe it's fine. We can try it out, right? Let's just call it. So what we're looking for is like, yeah, simplex noise would be too expensive. So we're looking for like, based on the UV itself, sample it, give me a noise. And we will apply that to the overall distance value, including the border. That's the basic idea. Well, this N for noise, we just passed in the UV. Oh, we might want an FBM. Maybe. No. Let's just do one because, yeah, I think we can manually do a fractal Brownian motion. So I think this might be a bit too high frequency, but we'll see. We just want to basically take, so N would be, I forgot what N was actually. Well, we'll find out what N is. You know, if we add the noise, it's just going to make it look terrible. You know, let's have some fun for a minute. Let's do the sine of this times time. I'll just sine F. Give me a minute. I don't know why it didn't work. We just got to do this. Once a stream, we've got to do this. Why is it not? Why is it not like changing with the my? Oh, the results probably staying the same, but here we go. Not very nice. Ah, we need more zeros. Yes, I think this is like. So you want to combine different frequencies. It's definitely very noisy, isn't it? Why is it so? Hang on a minute. Do we want an FBM? But that's made it like 1.4 milliseconds. It's crazy. Is it because the time's in there? Shouldn't be. Does it keep grabbing the time every time? Yeah, so you're just adding in one noise function. Well, sorry, sine made it a bit more expensive, but yeah, the noise function, not very nice. Basically doubles the it takes twice as much time. So we've got to have a cheap unevenness. The noise isn't really going to help us. This is far too expensive. Not really doing too much either. So we do have the brick coordinate. But we also have the UV. So we could just take the UV and do stuff with that. So this will make it go out in a particular way, right? Oh, sorry, I got to do like a min. Yeah, there's things we got to figure out. So like, this is just going to offset, right? Like a scale. Kind of fun. Yeah, it's going from a particular end though. Wait, is my UV from... Yeah, the UV is from -1 to 1 in this case. Right. Okay, so negative makes it smaller. Right. Okay. But you kind of have a bit like an obvious pattern, but maybe an obvious pattern is fine. I reckon you could probably do some kind of gridded like repeat, basically SDF repeat. Use the infinite one. The position would just be UV. And then spacing would just be some kind of small number. And basically you pick like the min element of this. Now we can optimize this out by just inlining it. That's the basic idea of what you want, I think. Because we only want to do it on a scalar, not really a vector. Yeah, how often does it repeat? The pattern. Hmm. The UV is smooth and so is... Anyway. Let's see if we can get something... Right, here we're getting something. Doesn't look good, but... Yeah, it says repeats every 2 bricks or something like that. Yeah, maybe you can chuck it into sine, but sine. Yeah, maybe just chuck UV into sine. Maybe not min element. I'm not really sure. So that you -1 or 1. I think that's kind of what the range you'll want. Right, let's make it a bit obvious what's going on. So sine. It's already in a range of 0 to 1, isn't it, really? And it's going to be a gradient, yeah, so... Hang on a minute, why is that cheaper? What's gone on in terms of the performance? Apparently that made it easy to optimize. Oh, right, probably because this is just not really stepping anywhere. Okay, cool. Yeah, sine was a bad idea. So trying to add some bumpiness to it. So yeah, I guess you could just say times by, I don't know, how many? Yeah, maybe 16. Always has to be a power of 2. Right, we're getting something here. Do we do this and just makes it a higher frequency? Right. This is kind of looks higher frequency, and you're seeing things which are different, but then I don't know if it's... But it's kind of boxy. You can kind of... So now... So now how do we make it a little bit uneven? So you've got a range from 0 to... Let's keep it like that for a minute. You've got something high frequency, right? So you've got sine of UV multiplied by some big number. Sine is kind of cheap though, isn't it? But I wonder... So I wonder if you can do like dot, just swizzle it a bit. Do like a zy x plus a uv dot yz x, right, plus a uv. What does that do? Right, it's done something, that's for sure. Now, is that a bit too high frequency now? Well, sort of see it in patterns though, I think. That's why that sort of hash thing was kind of nice. That noise function was kind of nice. But it's too expensive. We just did this one as well, it wasn't too bad. Got an integer part, got a fractional part. Did this sort of thing. Did this hash function here. This is noisy. But then it takes different noisy values and interpolates between them. See, part of the problem is we're running this every single frame. No, sorry, every single time you step through the distance function. Right, you know what we'll do? I'll save that for next time. Let's just start cleaning this code up a bit, and then we'll worry about the noisiness next time. So the other parameter was, yeah, we wanted to add a new parameter. It was this border deepness. Right, border deepness allows us to, where is it? Yeah, that's the deepest border. Do that. 0.5. Yeah, cool. It's nice. So, oh, hang on a minute. Could border deepness add issues with? No, I don't think so. Cool. Right, so I'm going to put that as another parameter. So let's get changing that in code file. So I want to add a brick for a border deepness. Border ratio and then border deep. They're all kind of ratios though. So borderiness. What's the borderness? The borderiness. So border ratio is basically like given the brick, the size of the brick, how like based on this how big the spacing is from one brick to another, how much of that is a border? Right. So I think maybe border ratio is a good name actually. There we go. So right. So I think we should drag some of these. The colors can just go up here. Then do all the packing stuff. So we've got one word there. Next word. Yep. So nice. Border deepness, gloss min, gloss max, brick offset X. I like it. We just need to go ahead and go into graphics VK. We need to also set the yeah, you can make quite a lot of different brick stuff with this. It'd be really nice. That'd be cool. Border deepness 0.5. Quite flexible. Do 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 do. Right, so let's change the shader. So the shader. So we load the words up into there. Yeah, it's not added any more words, which is good. So we can say brick roundiness. Then the border deepness. These are brick material. Lovely. Lovely. There we go. So let's chuck that in. Now, can I change this? Something's off. Right. Brick offset Z, don't need that anymore. Oh no, this has been completely buggered. Don't worry about it. Right, so what are you complaining about exactly? Where's the... Did we add any more or something? Unevenness, roundness, deepness, brick counts, brick dims. I think they're all set. Yeah. I reckon... we didn't recompile it for some reason. That's my guess. My guess was wrong. Right, let's double check these quick. So, edge unevenness, edge roundness. Edge unevenness, edge roundness. Brick edge, those three there, good. Offset X, gloss min max, yep. Deepness, border ratio, yep, and the brick counts. Yeah, so they're good. So the deepness... yeah, that's fine. Oh, that's interesting. Do we keep that? Right, let's put that back to 0. Wait, 0 deepness, so it's not nice. Well... Right, I guess we'll bring them in one by one now. That's okay though. So let's start off by getting rid of that. Okay, good. Let's bring in the brick roundness. Right, that wasn't the problem. Let's bring in the border dims. All 0.5. This is 0.3. Right, could be part of the problem. And you've just changed the number of bricks. From 6 to 5. Oh no. Right. I don't think the encoder file changed, and therefore all the other things didn't change. Something like that, I imagine. I don't know. No. There's something about... Let's do the printing, because this is just bizarre. This was at... $61 bricks, 66 bricks, 129 bricks. Clearly, we got the wrong numbers. Not very nice. Oh. Why? So that'd be encoder. Yeah, this is old. This is not regenerating properly. That's why. So regen broke. Graphics. Get rid of these guys. Give it a regen. uh So brick encoder database. What's the database saying it is? Yeah, it's the same file, isn't it? Yeah, so I think what's gone on is, well, based on what I'm seeing, yeah, they're part of the wrong bit field. Right, so it seems like the bit packing auto gen is a little bit busted. It seems like it works great. Wait. No, it is fine. That's fine. That's the structure we have, isn't it? So take a whole byte from that, add 0. Nice. Do 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 do. Clamp it. Clear. Throw it in there. Seems alright to me. Do 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 do. So it might be that something else came on top and trampled it. 61, 60. Oh, these are not compiling. Oh no, right. So what happens? Let's see, right? What this is. Five. Is it like not recompiling the shaders? Surely. No, of course it's recompiling the shaders. So, but literally, we're using the same. Right. $61 instead of 5. Oh, I know why. We reordered the words. Ta-da! Problem fixed. Right. There we go. There we go. Right, I'm glad we're where we are today. That's good. So we want to sort out passing brick deepness here. Sorry, border deepness. Cool. Where's the roundness at? The roundness. Oh, roundness of 0.5. You're telling me that's 0.5? Feels like a lot to me. Well. Hey there, Sempiator. Oh, wait. Sempiternal facility. Welcome. Welcome, sir. Yeah. Lord Jesus Christ is King. Amazing. How long have you been a Christian for? Ah. 2 years. Amazing. Yeah, so I've been a Christian for, well, probably a lukewarm Christian for a little bit, probably 5 years now, but properly saved probably over the past year or two. But yeah, very gradual for me. Just waiting for the Lord Jesus to come and collect us all up. Seeing the world falling apart. So I'll keep doing his work until. Hang a minute. Why is this thing completely busted now? He's got to keep doing his work until. Oh, I see the problem. The problem. Until he comes. There we go. Beautiful. Look at that. Oh. Amazing. Let's go. Yeah, we're doing like a game engine basically. Just getting the tool in. It is mainly to build like Christian based games, if you will. So like probably set in a certain sort of era, if you will, on planet Earth, obviously. Right? So it's gonna be geared towards that. You obviously can't ever make a proper general engine that suits every single game. It's not gonna be specialized to making those sorts of contents basically. We'll see though, because you might have some like heavenly scenes or something like that. I don't know. We'll see how things go. But yeah, the idea is to make sort of like content creation pretty nice. It's going to be limiting in certain ways, right? Because that's the point of art, right? You provide constraint such that um things become easier to use and less to think about different things. So I'll basically be providing like a bunch of different materials and tools to place these things down and build different meshes from base primitive objects and, animate them and stuff like that all in the engine to make the workflow really nice and easy to use such that it's not like a complete spaceship to try and use it. Um, and then yeah, when the sort of basic tools are in, like, you can make meshes, move them around, that sort of thing, animate them, and, have some basic lighting. Then from there, it's like, right, I think I'll be doing this over the time. Whilst I'm doing this, I'll probably doing lots of praying and researching, reading my Bible all the time and learning more and more as I go. So, you know, basically asking God, so what's the best thing to do? Do we do the gospel? Right? The gospel is like the most important thing. But then is it kind of done enough? Is it should my first thing be about the gospel? Sorry, be the gospel. That's what I meant to say. Or should it be something that sort of is not necessarily the gospel, but kind of contains it in some way? These sorts of things, right? Do we do, what story do we do first kind of thing? So, and obviously you want to kind of keep it small, tight, that sort of thing. Don't want to go too sort of like big. But yeah, lots of praying. Probably have to do fasting at the same time, right? Pray and fast and figure out what that is. But that probably won't be for another year or two, I think. Is that job which you're doing on GPU? Hey, Davos. So this is just a cube, but the material is a 3D material, and this is a normal map based on after ray marching into the material and just by using a bunch of signed distance fields. So basically the answer is probably yes to your first question in a way, but in the pixel shader level, right? So there's kind of like the mesh is a box, just a flat cube, but there's kind of geometry in the material that we're ray marching against. So it's kind of interesting. I think we're going to do this for a lot of our stuff. Yeah, like a volumetric texture, exactly. So we're going to be doing, all of our materials are probably going to be kind of something like this. It means we've got to be very careful with like, very limited what we can do. But yeah, maybe they're not all going to be ray marched, but there'll be a certain set of materials which are ray marchable. like the brick, like all the base layer stuff, the stuff which is like an additive, not really additive, but a layer on top which goes on top of the material, like maybe like a moss layer or something like that. That might be, uh, yeah, that might be something else. We'll see. That might not be a rain marcher. But yeah, it's pretty cool. Yeah, it took us a while to get this function though. I tried all different things, but yeah, it's been. But the geometry is all in place now. We just got to color it and add a bit of noise. But it's all completely configurable with like all these parameters. So it's pretty cool. There's like, how many bricks do you want? Well, these are the guys. How many bricks do you want? What are the colors and all this? So you should be able to do a wider range of different bricks. And yeah, be nice. Same sort of thing before when you don't need surface UVs, I guess. Yeah, exactly. Yeah, so with this one, it has got a bit of a problem. You see the sphere at the back looks terrible because it's not designed for spheres. Because the cement layer is done by just being a side distance filled box. Maybe we could change it. We can also change it to a sphere by just a switch of, a little bit of a code change. And it does make the sphere one kind of look all right. But it's not designed for spheres. It's designed for a box. Now, it doesn't mean we can't have paths, because what we're going to do is the following. So, like you have the bitangent and tangent in classical 2D side, textures, you're going to have a similar thing, but it just tells you how to warp, how to rotate the ray marcher, basically, right? So this will be along the x-axis, and the UV is just dotted along there. The y obviously would be up, and the z would be that way, right? But you basically just define which way goes along the wall with these vectors. And you might need just one vector if we're going to be making the path exclusively go. The y could just always be up, right? You just need the x vector, like where is it along the ground? And we can just encode that as in a vertex. And yeah, it'd be cool. We've got some problems though with so bricks weren't as regular in Palestine though. So if you're going to go through some of the Bible related, you might need different material. They did they really have them in those? Yeah, not necessarily maybe the brick as in terms of like these sorts of bricks. Like you're talking about like these bricks, right? These red bricks. Maybe not these ones, but they probably had. Did they have? They might have had some other ones though, right? I'm not sure. But yeah, we're not necessarily limited to that sort of place though. They have mud bricks more over them than irregular rocks, I think. Okay. But yeah, that's fair. It's fair. We will be doing like a rock one, I think, like a rock wall. I think we can try the Voroni noise. But yeah, we'll just be doing the Voroni noise. Something like this. We could probably do like a Voroni noise based wall. Stuff like that, basically. And that should be. But yeah, we'll see. We gotta play around with it. You get stuff like that. Awesome. Right, guys, if you want to chat in the meantime, we've got a Discord channel. And thank you for everyone who's supporting the channel. If you want to support the channel, get access to the code on your machine. You can become a member via Ko-Fi and support the channel as well. Thank you for everyone who's doing that. Next time, so the stream schedule is down below. So we're streaming on Tuesday, Thursday. We sometimes do a Friday stream, but this Friday I'm gonna have to skip it because it's my birthday, and then Sunday there'll be a stream. So I'll post on the Discord in the announcements channel. So if you guys want to see like a summary about what we're doing in the next stream, I just post it in the announcements channel, and obviously free to chat about stuff in the meantime as well. God bless you too. Thank you so much, Duke of Cool. Thank you so much, sir. Appreciate you. But yeah, I hope you all have a good start to your work week. And yeah, God bless you all. Thank you so much. Have a good one. Much love. Bye.